Hello and welcome. What if I tell you that what we are going to study today is a transformer model, which is the backbone of generative AI. So what you see today in form of the ChatGPT or any new generative AI features that are coming up from different cloud vendors, the heart and soul or the backbone of it is a transformer model. And now this transformer model is a type of the deep learning model that we should be aware of. So what is a transformer model, right? So first of all, again, as I always say, look at the root word. So whoever actually coined this term transformer model, why did they coin the term transformer? So you must have studied sometime back in your physics what is a transformer? If we talk about the electric current or electric circuit. So transformer is actually a device that transfers electric energy from one circuit to another circuit. So if you see here, there is this circuit C1 and there is circuit C2. So all this transformer is doing, it's transferring the electric energy from one circuit C1 to circuit C2. Now, we are talking about transformers in neural networks. So transformers are a type of neural network architecture that have revolutionized the field of natural language processing. Very important, right? So this is basically a game changer. It is a game changer in the field of NLP or the natural language processing. And some key points that we need to be aware of are, now, you can easily correlate. Once I have shown you this diagram and I show you this diagram, this is actually the architecture diagram of a transformer, right? Now, you can easily make out that yes, there is this layer. So there is some energy like here we are transferring the electric energy from one circuit to another circuit. Here you are transferring the information or the data from one circuit to another circuit, or you can say from input to the output, right? So this is how the architecture of a transformer model looks like. So you have the input layer and you have the output layer, and there is a feed forward network, and there is a concept of encoders and decoders. So now you may ask, but what is an encoder? So encoders are neural network layers. First of all, remember, there could be multiple layers of this, right? So we are just showing one layer, but in input itself, there could be multiple layers. In output, again, there could be multiple layers, right? So encoders are the neural network layers that process the input sequence and produce a continuous representation. Or we can always say that it is kind of the embedding of the input, right? So it is producing a continuous, say, representation. And now again comes what is a decoder, right? So the decoder uses these embeddings to generate the output, right? So, and don't worry if you don't understand it, we'll understand with an example as well. So for the moment, just understand that transformers use a unique architecture primarily based on self-attention, right? I will explain you for the moment. Understand that attention means context, right? So this model is aware of your context. It knows what you really want, right? So transformers are a unique architecture primarily based on self-attention mechanism, allowing them to weigh the importance of different parts of input data. So in terms of the input data that you are getting, it can look at the weightage, or it can look at the probability that which is the one, or which out of these data sequences should be the one that I should pick, right? So there is, for the moment, just remember, just like a normal transformer, you have a layered mechanism and you have a feed forward network, and you have a concept of encoder and decoder. From encoder, the information is going to a decoder, right? And very important, unlike the previous sequence-based models like RNNs, which was the recurrent neural networks, and the LSTMs that we studied, transformers process the entire sequence of data in parallel. And that's why you look at the speed. Look at the speed at which ChatGPT generates your data, right? You just simply say, write a poem or write a letter for me. And you will say in a matter of few seconds, it's able to generate it. Because it's already trained on humongous amount of data. And from that data, trained data, it can draw inference, right? So, and all this happens parallelly. Now, if I again give you example of RNNs, what we studied with RNNs, it was more of like you were saying, hello, how are, then it is looking, okay, this could be the possibility, this could be a possibility, and you're saying, okay, you pick U. So this is kind of an autocorrect as well, right? That you normally use. So this is a concept of RNN. But here we are saying it is all happening in parallel, right? When you're writing a letter, when you're writing a poem, when the generative AI is doing it for you, right? So this model is that intelligent. Now comes the very, very important point that you need to understand. Here I gave you some hint about attention. Now we need to understand what this attention means. So the core of transformer is attention mechanism. So I would say, if you even don't understand the architecture, if you even understand the basic concept against for a transformer model, I think the job is done. So the core of transformer is attention mechanism, which allows the model to focus on different parts of the input sequence when producing the output, and enhancing its ability to understand the context and relationship in the data. Now it's very important. Now attention is directly related to the context, right? So this model is so intelligent that it understands the context. So it will understand the context based on the input you are giving. Now a very good example we always give, that if in one sentence I'm saying the bank of the river, or I'm saying money in the bank, right? So that's the beauty of English language, right? One word can have different meanings. So there is one word but different meanings. So here bank of the river is related to a river, and here money in the bank is related to the money that you have in the bank. Words are the same, but the context is different, right? So this model uses the attention mechanism. So when the information is fed from one layer to another layer, it will still keep a note of the context. It knows the context. It won't start using words or sentences which are out of context, right? That is very important. And this is how it works. Now here again, we take an example of writing a story, right? Let's say you are telling your transformer model, can you write me a story, right? 95% of the time or 98% of the time, you will see that whenever we start a story, we always say once up. So we always start with once upon a time, right? So once upon a time, we say that, right? So that is the concept how the transformer works, right? So here is a concept of softmax, right? Now you may say, what is the softmax? So softmax layer actually turns the scores into probabilities, and then these are used to pick the next word in the sequence. And you know, this actually continues like this. This goes from here, next one. It actually keeps on going like that. Now here you're saying let's say it has to write a story. Now you could start the story with once, you could start the story with somewhere, you could start from there, you could start from Zigote, and then what it does, it actually gives a kind of a weightage, and it looks at which one is best suited as per my context, right? This is the key here. It knows, oh, I have to write a story. It means my sentence should start from once. So it picks once, then it's fed. Then it says, okay, what can be after once? So it can be once upon a time, or it could be once there was. So same way, it will look at the context. Oh, I have to write a story. Probably best way would be once upon a time. So it goes on like that, right? So very important. With transformer, you have a layered mechanism, and you have to look at the encoder component and the decoder component, right? So, and transformers do not require recurrent layers. As I told you, that it is not sequence. It is happening all in parallel, and all this work that you're doing is happening all in parallel, right? And that's why it's able to generate so much data within a few seconds, right? And the parallel nature of transformer makes them highly scalable, with increased data and computational resources leading to improvement in performance. So that's why there's a concept of GPUs these days. GPUs are becoming very popular. So you'll see when we study our AI architecture, or the AI infrastructure, I should say, GPUs, just like CPUs, you have GPUs with the graphical processing unit. And the beauty of GPU is that you can have thousands of GPU, or you can say thousands of cores that are running in parallel, right? So that is the thing. The parallel nature of transformers make them highly scalable. And yes, as I said, there is a layered mechanism. What I show here is encoder decoder, but within each encoder or a decoder, there are multiple layers, and these multiple layers are called transformer blocks. And there's a feed forward mechanism. And as I said, attention is very important. Whenever it's fed from one block to another, it knows the context. Like the context we talked about, money in the bank or bank of the river. So transformer is nothing but a concatenation of many transformer blocks. So it is composed of multiple transformer blocks, and each one of these is composed by an attention component followed by the feed forward component, which is a neural network. So very important. So as I said, a typical transformer model consists of encoder and decoder, what we showed here, just like a transformer here, encoder and a decoder, and each comprising multiple layers. So every encoder, every decoder would have multiple layers of self-attention and feed forward neural network. This is the key here. Self-attention and feed forward neural networks are there, which creates a transformer model, right? And all throughout these, you will see the context follows, or the attention follows. So transformers have become the backbone of many state-of-the-art NLP models, or the natural language processing models, such as machine translation. So even in translation, you can use, let's say I'm translating English to German. Over there, you will see the transformer model getting utilized. Text generation, something like these days we are talking about ChatGPT, summarization, and question answering. So for all these things, wherever you think that things can be done really in parallel and it's not a sequential thing, then this can be used. And the notable implementations of transformer model include BERT. It's again getting very popular. So it's called the bidirectional encoder representation for understanding the context in language, and GPT that I just talked about, the ChatGPT. Don't worry about it. We'll do more deep dive into ChatGPT or GPT. Why GPT is called a GPT. And when we study, you will see and you'll be surprised that GPT, the T actually stands for a transformer. So it's very important that's why we are studying a transformer model, because as I told you, the heart, the soul, the backbone of ChatGPT, the GPT models, is transformer. And so it stands for generative pre-trained transformer, which helps you generate human-like text, right? And beyond NLP, yes, so there are various use cases beyond NLP or natural language processing. It can be adopted for other areas like computer vision and audio processing as well, right? Again, as I said, wherever you think that things can be done in parallel and where the context is the core of the whole thing, then the transformer model can be used. So with this, we come to the end of the lecture on transformer model. Thanks for watching.